We will try to be sharp and in exactly 2 minutes continue with the presentation in exactly 2 minutes so that it can be streamed like the rest of our meeting. After that, if we are disciplined, each speaker has 15 minutes. It means that there will not be much time left for a debate. But my proposal, and you probably hate me for this proposal, is that we go on until the foreseen time, that is 1, with the presentation. But then since we have 2 hours lunch break and we started later, I suggest that once the stream is finished, we might have some 15, 20 minutes of internal debate. Above all, come to the some proposal and not only, a summary of various presentations, if you agree with me. It's, I think we 30 seconds, we can restart. Okay, it's 11. Please, the floor is yours once again.
Hello again. Again, we resume the presentation that I interrupt. So here you can see the precipitation, so the projection of global precipitation at 1.5, 2, and 4 degrees of threshold of global warming. And you can see that there are regions where the precipitation is going to increase, and the other regions with is predicted a drought. And in particular, it's one of the regions where the drought is going to be more severe as actually the region of the Mediterranean, and another one is the southwestern of Australia. And so it is undisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and droughts, more frequent and severe. And because it's not only a question of the average of temperature or precipitation, but the point is actually related to the extremes. And here you can see, for example, it's a map with the world is divided in different regions, on the continents, and you can see that this is the change in hot extremes since the 1950s. And basically, when there are 3 dots, you can see that we have a high confidence that these changes can be attributed to human activities. And you can see that almost everywhere there is 3 dots. So basically, this is a very big thing. And not the same for precipitation. Here is the same map for heavy precipitation. And basically for heavy precipitation, there is a lot of more uncertainties because the precipitation is a field which is not so easy to interpret. And for the future, so basically the changes that we have seen can increase with the further warming. And here you can see something related to the future. And basically this is hot temperature extreme over land. And for example, if we look at 10-year events, so events that usually in the past happened every 10 years, well, nowadays, if they happen every 10 years in the pre-industrial period, nowadays they happen in 10 years 3 times. With the 1.5, these 3 dots becomes 4, and with 4 degrees, basically an event that in the pre-industrial times happened once in 10 years will happen almost every year. And in terms of intensity of the event, what was 1 degree in the pre-industrial period is 1.2 more in the present times, and is going to be 5.1 at 4 degrees. So it's really crazy. And and this is for a 5-year event, same as before. This is for hot extreme, but if we look at, for example, to the heavy precipitation, we can see more or less similar things. So basically, this is an event every 10 years. Sorry, here I'm a bit clumsy there. Okay. Okay. Yeah, so they are going to increase as well. Here it's one probably my penultimate slides, and this is, you can see different indicators of climate change for the future. This is the temperature. This is the sea level rise. Here we have the acidification of the ocean. This is the melting of the Arctic, and this is temperature. And you can see that in any case, we have a big increase of changes and collapse in the case of the Arctic. And last slides is about the fact that basically we know now that actually there is a proportionality between the CO2 emissions and the global warming. And basically, looking at this proportionality, we know that we have still 400 gigatons to emit to reach 1.5 and 1,200 to reach 2 degrees of the global warming. And at the moment, we are emitting at a rate of 40,000 gigatons per year. So basically, we have 10 years to around 10 years to 1.5 and 30 years for 2 degrees. With this, I can conclude. So in some changes, there is no going back. But other changes could be slowed and others could be stopped, limiting warming. So the climate we experience in the future depends on our decisions now. And thank you for your attention.
Thank you so much. As your colleague and friend Antonello Pasini says, the good news is that we are the cause. Because if we weren't, we could do nothing. But since we are, we can still save our planet. It is now the turn of Coronel Papito, who is the real soul of this meeting, although I have the microphone. Coronel, please, the floor is yours.
Thank you for the information regarding the French Revolution. I have to improve my knowledge regarding the history. Oh, okay. It's a pleasure for me to stay here to speak regarding that smart forest monitoring, the Italian proposal to check the forest by satellite. We presented this slide in the World Congress of Forest in Seoul last May, and it is a pleasure for me to present now. Well, where is that? Here. Okay, the forest. The forests are very important because they represent 36% of Italian surface, and the last National Forest Inventory told that 11 million of hectares of forest are in Italy. But maybe the most important information regarding climate change is that 2 billion of CO2 tons are stored in the forest. The forest is a strategic issue for us, and this is why Carabinieri works in these matters. Forests are the biggest carbon stock on the earth. We have 2 carbon stocks, one in the ocean and one in the earth. We can work just only on the earth. And so forests became the most important, our strategic issues. The National Forest Inventory that Carabinieri carry out every 10 years in 9,000 simple points is a very important instrument to respond to the international report, in particular national inventory report from the Kyoto Protocol regarding the international climate change, and for the FAO report regarding the World Forest Inventory. Okay, sorry, I go quickly, I hope. Okay, but we want to use new technology. We want to have a modern tool to do the monitoring of the forest. And new tools that use the Copernicus instrument of the satellite, and that is okay for the SDG era, okay? So we want to protect the forest, we want to predict the change in the forest using the Earth observation and artificial intelligence technology. How can do that? We think that the use of a multi-sensor and multi-temporal approach is a good idea to monitoring and prevent the problem of the forest. So we think to this smart forest monitoring using the remote sensing satellite, the ground truth analysis, because we have 900 forest station around Italy, and more or less 7,000 military people that do the control of the territory. And with that, we can do action regarding two things. The first, when we have an illegal use of the forest, we can do our law enforcement activities. And the second one is to inform the agency that manage the forest regarding problem, regarding what happened to their forest. Okay, what we do now? We have an approach bottom up. We have 900 forest station, 7,000 people on the ground that control, that check the forest. They report to higher command, and we have the evaluation of the report, and we give them the information what they have to do. Tomorrow, we want to change this approach. We want to have a top-to-bottom information system. We want that satellite in the space give us information regarding spectral anomalies, give us a coordinated geographic coordination of the point, and an early warning report arrive directly to our station, where they could do a ground truth evaluation and give us what is happening in that point. These are the principal goals. These activities are very useful for national inventory of the forest. This use is very important to understand the loss of the canopy coming from fire, forest cutting, illegal forest cutting. We could have information regarding the slow change of the vegetation status. For example, in case of parasite attack. Parasites are very important in the future, in particular with the climate change. And then have early warning to do an action very strong immediately on the ground. More or less, this is a line where we have now in our activities. More or less, we have the alpha testing platform. Oh, sorry. Where we start? from what just exists. The Global Forest Watch is an web application using the satellite that in near real time could give us information regarding legal deforestation and monitoring the situation of the forest. Global Forest Watch application is used by this organization and is the collaboration of a lot of partners. Here we don't have the connection, sorry, but I invite you to go to Global Forest Watch to see the opportunity to have real information regarding the change of the situation, the change determined by the cutting of the forest in the first case, and now in the case of attack by parasite. This is the overview of the flowchart. We have a collaboration with National Council of Research, and they have now working to the algorithm. When we launch the algorithm, we have the identification of anomalies on the spectral of the response of the forest, and now we are using as a computational platform Google Earth Engine, and as a sensor, the free sensor of Sentinel-1, Sentinel-2 of Copernicus constellation of European Space Agency. When we launch the algorithm and the identification of an anomaly, we send the information to the people on the ground, to our forest station, and we detect what is happening on the forest. Google Earth Engine, I go quickly. This is Sentinel-1, Sentinel-2, 10-meter pixel site, weekly acquisition of the image, automatic update in the Google Earth Engine database. Sentinel-1 is an SAR sensor, Sentinel-2 a multispectral sensor. With this, we can do this algorithm. We analyze the data, we give information to the station, and we could have a response to our people on the ground. But this is the second phase. We have a new partnership, a new satellite, new algorithms. In particular, we have also the CREA, that is very important for research in agriculture and forest, and Massachusetts Institute of Technology in Boston. We want to be more efficient, more fast. We want to use artificial intelligence. We want to use IDG technology, and so we propose to our partner to use this kind of technology on the new satellite. What I don't know, but with next generation fund, we have a 3.5 billion euros that are invested in space economy. So we will have in 2026 a new constellation. The name is Iride constellation, new Italian satellite for the observation of the Earth. And we, as Carabinieri, told to the decision maker that we want on the satellite hyperspectral sensor and synthetic aperture radar for do the smart monitoring of the forest. why we want to have this kind of sensor? Because with this we can really have an important data coming from the satellite, and we can do the monitoring of the forest in the best way. We wanted to have also, in particular, a spectral sensor because we know that some document of the Commission told that it's very important the control of the parasite because the insect, there are 5 alien species that have a big problem for the next forest because we know that with the European Green Deal we want to plant 3 billion trees, but if we have a parasite that kill forest, the action will be vain. This is the new algorithm that we will be improve, and we have the opportunity with the use of a new satellite to have a daily acquisition of the information. We can use hyperspectral and SAR sensor. We can have an ADG computing to do the check of anomalies on the spectral. And if we have a true response of the information, we can do the same thing that we have done in the first phases. If we have a false information regarding that, we can give to the satellite, to the intelligence artificial that we have on the satellite, the information. So with machine learning, we can improve our algorithm. Okay, thank you very much for your attention. Here you can have you have the information regarding my email and the mail of my colleagues La Saponara. So if you have a question, you can send us all your answer. Thank you very much.
Okay. Thank you, Colonel. Precise to the second, I must say. And I will give the floor to 2 more speakers who actually will develop the same approach and the same project that has been presented by Coronel Papito. Just allow me to remind that forests are not only essential as carbon sinks, they are the heart of most of the services, of the ecosystem services, without which mankind could simply not exist. So our next speaker was mentioned in Coronel Papito's presentation, and she's going to explain how the CNR, which is the Italian National Research Center, cooperates with Carabinieri to make this program come true. We are talking about Dr. Rosa La Saponara. Please, the floor is yours.
Thank you, Mr. Chairman. It's my pleasure to stay here. I thanks very much all the organizer and Colonnello Papito in particular. My presentation is relating to the data, platforms and algorithm, of course. I would like to start with the platforms, and as Colonnello Papito already highlighted, we use Google Earth Engine. Google Earth Engine is free of charge, because if we would like to monitor the whole Italian peninsula and maybe much more, what we need is the sustainability from the economical point of view. Google Earth Engine is free of charge, and we can access to a lot of data made available from ESA and NASA. That's why the main point was to select the best with the lowest price. So the main point was to develop some algorithms suitable for long-term satellite time series analysis in order to have useful information, because of course a satellite cannot stop climate change, cannot do anything, but what is very, very important is the fact that can provide useful information. So our task as a research and in our cooperation, what we do is to extract this information, effective information, and of course, as Colonello Papito highlighted, then in the field can be checked. That is the main important point. What is really important, so, is to develop these sustainable tools, that means free of charge, and in the next future, these tools can be also used not only in Italy, but also, for example, but not only in third country, because the platform, as it is now, is very, very easy access, user-friendly, and if you need to use, you don't need to be expert in remote sensing. What is, I would like to show you in the next video, is the possibility to have these results absolutely online and also updated in real time by Google Earth Engine. We made this investigation using Sentinel-2. Sentinel-2 is multispectral optical information, and we can have information at 10 meters. As maybe in the next presentation, we will have additional detail. Today is possible using satellite to have a very detailed information. This information can be less than 1 meter, that means 0.3 meters, but is generally not available for free. We need to pay for this. And that's why my first consideration was sustainable from the economical point of view. So the main point was to have this. This is an example for the Lazio region. And as you can see, it's quite easy because the end user has to select the area, can be the region, can be a subset of the region. And what we implemented here is the algorithms to have for this long-term time series. Sentinel is available starting from 2015, and you can select the period, you can select the geographic area, and you can have these statistics also in a very detailed way from the spatial point of view, but also as you can have in the next snapshot, the level is the station level. Of course, the most important point for the remote sensing is the validation. So we made validation using, I will show you in the next presentation, some region of interest, and it's covered by my face, but the accuracy is higher than 19%. And this is very, very important because we can have a nice picture from satellite, but we need to have effective information. This is the main point. And it's a pity because it's covered by my face, but in the red rectangle, you can see the statistics, and you can have the information at the station level relating the gain and loss. Of course, the algorithm we implemented is, you can see here some detail, and as you can it's so small, but you can have information for each different station in Lazio, and you can see the single pixel. So this is the main important point, to have very detailed information for free. And this is one of the most important aspects for us, because we would like to have the most sophisticated with the lowest price. Then I would like to provide additional detail about the algorithm with my presentation. The presentation starts with these quite fast. The author of these, I don't know why.
Sorry.
Okay, thank you. Okay, I don't know why. No, okay. We can go fast because I would like to show you the algorithms, the rationale. Our approach is generally based on integration of different sensors, different scale, starting from the satellite, and so we can integrate this with the so-called close range. We can have also the possibility to, we used to work in the last 20 years, not only in Italy, but also in different areas, from Northern Africa to South America, China, and we have some stable cooperation with the Chinese Academy of Science, the Brazil Space Agency, Argentine Space Agency, and so on. So the main point is that we used to work with the big data. Big data is not only big, but is, of course, the integration of different readable data. And the main point is that we have all of this data. That's why we prefer to use Google Earth Engine, because all of this data needs to have a very, very big storage. And the role of Earth information is to use as much as possible these, because we can have not only historical archive, but we can have also the systematic monitoring, not only for Lazio, but for the whole peninsula, for the whole Europe, and of course, at a global scale. I would like just to show you that, of course, the use of satellite time series is not new. This is one of my first publication in the field using AVHWR. It's very, very old data, but it's very interesting because, as you can see, when we need to explore this data, we have the seasonal dynamics. And of course, as Colonnello Papito highlighted before, we are interested in a subtle feature. Parasite as not so strong as the seasonality. So we have a lot of a challenge, because to extract this useful information, we need to arrange suitable data processing in order to remove the seasonality and to process the deseasonal, the detrended signal, because this is a signal. So still today we have a lot of open issue and also a challenge to address. All of these are very interesting from the research point of view, but of course what we need to do jointly is to move from our laboratory to the society, from publication to operational application. That is the most interesting challenge. Of course, the idea is to use artificial intelligence. Generally, artificial intelligence means different approach, deep learning, neural classification. But what is interesting to highlight is that, of course, again, artificial intelligence is not new, it's old, very, very old, but the new can be the use of artificial intelligence for Earth observation. It's not exactly the same as you have a photograph. When we have a photograph, we are with our passport, it's easy because we have just the face and the very small background. When we deal with satellite data, we have atmospheric contamination. That means completely different situation. And also, if we think about the different temporal, the different condition over different months, we can think, for example, about the aerosol, the dust. This means that we can have a beautiful picture, but the signal is completely useless. That's why what is really important is to develop the data processing to assess the reliability. And using Sentinel-2, the main question for us was, it's possible to monitor using 10 meter as a sensor the single tree, and we made this experiment in Colosseum, because Colosseum has a pinus tree, using a Google Earth Engine again, a similar approach. And what we, of course, made was you can see different temporal behavior of different pinus tree, some in healthy condition and the other attacked by parasite. And you can see the difference in the spectral signature. And then, of course, the main issue is to move from the single tree to landscape level, and we applied the same not only to the Colosseum, but also in different areas. This is the situation in Castelvolturno, where you have, as you can see, a lot of impact, because there is the pinus tree completely damaged by the parasite. We applied not only in this area, but also in other areas, because it's very, very important, the accuracy. This is another example in Calabria, and you can see the detail that we are able to achieve. To be fast, of course, what we are doing now is to improve the analysis using Sentinel Sentinel-2 and Sentinel-1, and to move from annual to weekly and monthly information, and also to use this information as the basic for new information, for example, indicator for SDG, starting from the first evaluation, and also some useful information relating the ecosystem services using satellite data, moving from Italy, Europe, and maybe also other continents. That's all for my side. I thank you so much for your attention.
Thank you to you.
Thank you so much. We go, as I say, in a row again about the potentials of satellite observation for our goals. And I invite to speak Major Enea Viviani.
Okay. Good morning, ladies and gentlemen. I'm Major Viviani from the Space General Office of the Italian Defense General Staff. And I'll be very quick. And first of all, I want to thank you, everybody, because it's a pleasure to be here to introduce you, give you a quick glance to the Earth observation programs in the Italian defense and how the Italian defense is contributing to the development of the IRIDE constellation, which will be the next national and governmental Earth observation satellite constellation. Okay, may I have the slide on? Okay, so I'll give you a quick description of the Italian Defense Space Organization, and then I'll go into detail on the IRIDE and structure and its development phases, just to show how the defense is every day showing growing interest and attention and involvement in the topic of environment monitoring. We have a great cooperation with the Carabinieri and the CUFA, and that's why I'm here today. So, as everybody knows, space is a precious resource which enables a lot of activities nowadays, not only for military, but for everybody, every person on the world, starting from satellite communication to Earth observation, services of navigation, positioning and timing, and of course other issues. With that, with the great improvements that came with these resources, came also some threats which are unintentional, such as the debris and the space weather, but also intentional. And that's why the defense of all over the world are increasing nowadays are increasing their effort to ensure the sustainability and the protection of the space environment. And from a military point of view, space became from an enabling environment to a military operational domain in 2019. That's why also the Italian defense adapted and in 2019 established this two kind of organization, the Space General Office within the Defense General Staff and the Space Operations Commands, which are the strategic and the operation entities regarding space. Okay. Well. Okay, regarding the space capacity of the defense, as you can see, we have four capacities, which are the satellite communication, Earth observation, position, navigation and timing, and the space situational awareness. Today I will be focusing, of course, on Earth observation, where the Italian defense has a long time history, almost 20 years of experience in managing in cooperation with the Italian Space Agency and other international partners, satellite Earth observation systems. Here you can see a picture of the actual constellations and system that the defense is managing. So we have a couple of constellations of radar sensors, which are called Cosmos Skymed, which are were developed in cooperation with the Italian Space Agency, and they can grant a revisit time of a few days and a resolution which are submetric. And of course, we have optical sensors too. OPSAT 3000, it's an Italian-Israeli made satellite, which can give multispectral, panchromatic, very high resolution images, submetric, with submetric resolution. Of course, this is only military system, so it cannot be used for civil activities. And of course, we have access to other partners' images, for example, the French Composante Spatiale Optique, which is fruit of a cooperation with the French Minister of Defense. In the future, next future, let's say in the next 10 years, we are planning to develop the capacities. For radar sensors, we are developing the third generation of Cosmos Skymed, also always with the Italian Space Agency. And regarding the optical field, we are developing a third generation optical system, which will be in operation in, before the 2030. What the previous colleagues mentioned, and which is the great importance, is the development of the IRIDE constellation, which will be the next governmental national Earth observation constellation. It will be an Italian system that will grant governmental images to all the administration. So it's not only for military. The Italian defense is contributing to the development, but the constellation will be a national asset. So that means that everybody would be granted the access to the data, and with this will greatly integrate and improve the quality of data, for example, the Copernicus data that today are used. Okay, so let's go into detail of this new constellation. The IRIDE constellation will be founded with the EU Recovery and Resilience Fund and a part of National Complementary Fund. And it will amount of 1.3 billion euros, so it's a very huge investment, and will permit to develop and increase some capabilities that are still already present in different organizations. Above all, the climate change monitoring, then the country coastline protection, and the combat of the hydrological instability, the prevention of fires, and of course also the promotion and development of high-tech, both commercial and non-commercial application. As the previous two relators underlined, smart forest monitoring is a very precious application that will benefit in a huge way from this system that has to be launched and deployed before 2026. That's a mandatory deadline. So we are working with the industry, with the European Space Agency to realize this system. The system will be organized in three main segments. So the constellation, which will be a multi-sensor constellation, which means that there will be different kinds of sensors that I will describe briefly after this slide. And a ground segment in where we will receive, elaborate, and distribute, disseminate the data. And of course, 8 services that will give the service, so elaborated data, and foster also the national industry and the national, let's say, evaluation of data. I depicted 3 of these 8 services, which I think will be the most suitable for the interaction and the cooperation for the Minister of Defense and the Carabinieri, which are of course the security service and the emergency and land cover service. As I said, the deadline is 2026, so we have to move really fast, and this deadline doesn't permit to develop new systems, so we have to pick what is already available from the industry, from the national industry, and we are trying to put in the already available technology the requirements of different administrations. So there is a national user forum where all the ministries are involved, so from defense to environment to transportation, everybody is contributing with the high level requirements, and the CUFA of Carabinieri put their requirements as Colonel Papito already showed. These requirements are going into a system specs which will be elaborated by the European Space Agency, which is the contracting agency for this program, and hopefully will define a constellation that will answer to these requirements in a good way. This is a really brief presentation of which will be the assets, or which at this point of the study, let's say that at the end of the year there will be all the contracts. So now it's not definite the structure and the architecture of the system, but very probably there would be 3 SAR missions, 3 different SAR radar missions with almost 30 satellites, which will grant, of course, high revisit times, high revisit rates, and at good resolution. And of course, the technology and the cost and the time nowadays will push for an X-band constellation, but we don't know. Maybe the L-band will be. Then there is, of course, an infrared. There will be an infrared constellation and hyperspectral constellation, Prisma-like. 3 constellations of high-resolution optical sensor, and hopefully 3 very high resolution with a submetric resolution of data. The service that will be developed with this data, of course, can be feeded with this data, and there will be a development of services which we will follow. As the previous speakers enlightened, there is a very good implication of satellite data, which is a global access, persistence, information timeliness, and of course this data and here the data will give extreme high contribution to the activities nationwide and all over the world, because the data will be free, will be of of higher resolution, higher revisit time, will give really a huge number and variety of service, and of course will be suited to process automation and exploitation. That's all. So I'm available for any kind of question. Sorry for the quickness.
Actually, from now on, I only want to have panels with military people to the second. Fantastic again. Before I pass the floor to Dr. Anne Brantôme from FAO, just a small suggestion offered for collaboration. My organization, the Union for the Mediterranean, is currently developing a few apps together with Copernicus, very user-friendly. We will be launching them at the COP, and we will have an app for cultural heritage protection, one for transmissible diseases, one for energy use and energy production, and various others. I don't take your time. But I think that an important aspect in this phase is that Each one has to develop its own self-sustaining technology, but putting together is also very, very important. Dr. Branton.
Thanks a lot. So just to introduce myself, so my name is Anna Branton. I work in the FAO, in the Forestry Division, as a forestry officer, and more specifically, I work within the Global Forest Resource Assessment program at FAO. So I'm going to talk to you about the latest evaluation that we did on the forest, the global forest, the Global Forest Resource Assessment 2020, which gives a picture of the world forest since 1990, and look at the status and trends of the world forest. This is again to stress a bit the importance of the word forest, and I think it's in relation to what was said before on the balance of the different components of what we have on the earth. And as we know, all the forests shelter a lot of biodiversity, most of the terrestrial biodiversity on earth. It helps fight climate change. There are about 662 billion tons of carbon stored in the forest, and they absorbed 1/3 of the global emissions, so very important for climate change. And as it was said, they are a source of fresh water, timber, and many other vital products and services to humankind. And this is, again, to strengthen this importance of balancing and everything. It has been estimated recently that 42% of the global population live within 1 kilometer from a forest, that the ecosystem services are valued up to 7.5 billion USD, and that it's even more than what is being provided by the commercial industrial sector of the wood, which count for 1.5 billion USD. So they are vital. They are very vital for the national wealth and economies, but we know that they are facing immense pressure from different drivers. And it's very important to indicate that they are contributing to many of the Sustainable Development Goals. Of course, we know one important one, which is life on land, but forests are very important also to many of the SDGs, starting from food, climate change, poverty, and so on. Okay, so I'm going to talk to you again about monitoring and about why it's important to have updated, accessible, transparent, reliable information on the status of the world forest resources and their ongoing trends. And it's very crucial for halting deforestation and also to ensure that the different services that are provided by forests are taken into account in the different policy and decision-making processes. They are very important also this information at the global level to understand if all these international goals that are being set by the global communities are met. And if we don't meet them, how can we develop new rules and regulations or system to meet these goals? This is at FAO what we are doing within the Forestry Division. So we run this program, which is a long-standing program. It has started in 1948. And this is part of our mandate at FAO to support the countries in their effort to collect, analyze, and use the forest data to sustainably manage the world forest. The evaluations have been evolving over time. In the past, it was mainly FAO-driven. Now it's country-driven, and it's looking now not only at the timber aspect, but at all the dimensions of forest. The last evaluation, the FRA 2020, is one of the most comprehensive assessment of the world's forest, and it looked at 60 forest-related variables in 236 countries and territory from 90 to 2020. It's the most authoritative source of data on forest because it's based on official statistics. So we take data from the countries, we compile the data, we analyze these data, and we disseminate those data on the world, in the world. We use the same methodology for all the countries, which allows us to aggregate the information. And these assessments are based on a network of people that are nominated by the countries, which are the national correspondent, national correspondent. This network covers currently 187 countries and territories. In the last assessment, in FRA 2020, over 700 people, national and international experts were involved. So it's a major undertaking. And these national correspondents, they lead pretty much national teams of experts. We also complement the information that is being collected by the countries with a global remote sensing survey of the world forest. And the last survey has been just released at the World Forestry Congress in Seoul. And it's also look with the satellite imagery at how the world forests are changing from 2000 to 2018 to understand the dynamics of the world forest, but also the drivers behind the different changes in the forest sector. This is to give you an indication of what we are looking in this remote sensing survey. We have 400,000 sample points globally distributed. It was a stratified sampling design. For each of these small dots that you don't see because it looks like gray area, but where it's dark, there are a lot of points, and it's mainly where there are many changes in the forest happening. So we relied on local experts, which did some photo interpretation of high-resolution satellite imagery, including planet data and Landsat data. Over the period that I told you. In total, there has been 800 people involved in this assessment, and it's really the strength of this assessment, relying on the local knowledge of people who knows what is happening in the ground, and who can really interpret what is happening. And so now we'll give you a few of the key findings of the FRA 2020, looking at the results from the country reporting process as well as the remote sensing survey. And this is just a bit of headlines that went out in the news after we released the FRA 2020 results, which summarize a bit what is happening, that forest loss are slowing down, but not nearly enough. And this was posted in the Reuters. But of course, we have to look in the details because this is a global situation, but there are many differences from country and region to region. As we already said, the forests cover nearly 1/3 of the land globally, and you can see that there are different, most of the forests are in the tropical zones, 4.1 billion hectares. And then after the tropics, we have a lot of forests in the boreal, then temperate and subtropical domains, and this gives you the share of the forest. It corresponds to about 1/2 hectare forest for every person on the planet. I like this one because I think it makes us all feel that we're also responsible for a little part of the world's forest, and that it's like we had all 1/2 hectare of forest to protect. The forests are not equally distributed among countries, and only more than 1/2 of the world forests are only in 5 countries, starting with the Russian Federation, then Brazil, Canada, United States of America, then China. They are the top 5 countries for forest area, covering more than 1/2 of the world forest. As we already said, the world forest area is decreasing, and while the population was growing by 2.7 billion people since the 90s, now the world has lost 178 million hectares of forest, and it's correspond to an area of the size of Libya, which is a very big area. But as a positive news, this rate of loss has slowed down. And this is a very positive message. So thanks to the efforts of people, even if the population is growing, still I think we can slow down the loss of forest. And we can see that in the 90s, the annual rate of net forest loss were around 8 million hectares per year, and now it's about 5 million hectares per year. So this has slowed down, and of course there are huge differences between regions, and we can see that while there are major losses, in particular in South America and Africa in the last decade, there are positive gains overall in Asia, for instance, which has recorded the highest net gain in forest area in the last decades than Europe and to some extent also North and Central America. Oh, only 1 minute, okay. So, okay, this is a bit just to say that the net forest area change is also a summary of what is going, how forests are expanding and how they are being deforested. And we can see that the deforestation has been decreasing overall. This is where forest losses have happened, and these are results from the remote sensing survey. Forest losses are mainly in the tropics, and we could, thanks to the remote sensing survey, analyze which are the main drivers of deforestation, and agriculture comes as the first one. And mainly cropland expansion, oil palm representing 7%, livestock grazing being the second cause. Of course, there are regional differences. Also, we are looking at how the forests are, what type of forest we have. Planted forests represent 7%. Primary forests cover about 1 billion hectares, and they are really decreasing. We have started a special study on the primary forest recently to improve this data. This one I will not go, but this is also positive news that there are more and more forests protected, and we have reached one of the important goals of the Aichi target. We met that for forestry by having 80% of the forest area in protected areas. Of course, there are differences at the regional level, so which are very big. I don't know why it doesn't work. I think there is a problem with the batteries. Okay, positive news is that we have more and more forests with the management plans. But here also we have huge differences between regions. So while most of the European forests have management plan, very little forests in Africa and South America have management plan. And then we also look at the disturbances, and this will link to the next presentation, that fire is the main forest disturbances worldwide, in the tropics in particular. But insect disease and severe weather events have damaged the forestry severely, especially in the temperate and boreal domains. And just to stop on this last slide on the carbon stock, saying that it has been decreasing from 668 gigatons in the 90s to 662 gigatons in 2020. But carbon density has increased slightly over the same period. So at the same, for the same hectare, we have an increase in the carbon stock. And these are a few of the key products from the FRA 2020 and the report. There is now a platform that you can use to access all the data, which is open and easily accessible. And these are some key products of the remote sensing survey. And I would like to thank you for your attention. Thank you very much.
Thank you for this very interesting illustration. There is a change in program. Due to technical problems, we will have probably the intervention by Dr. Moser as the last one. And so we pass to another but very much connected dimension with Dr. I suppose, Alessandra De Marco, who is going to abord the aspect of air pollution and climate change.
Thank you, Mr. Chairman. Can you pass me? Okay, I'm Alessandra De Marco, working in ENEA. ENEA is a national public agency, and my skill is on environment, air pollution and climate change impacts on ecosystems. And in particular, a lot of activities I did is on forest protection. Why? If I have the presentation, it would be better. Okay, but anyway, the core of the problem is that the air pollution is strictly linked to climate change, and this is trivial, I suppose, but sometimes it's not recognized because normally we work separately on these two concepts of air pollution and climate change. You see on the left side the air pollution sources, traffic, industry, and so on, and fires, for example. And on the other side, the CO2 increase that lead to warming. And these two phenomena are working together. There is a synergistic effect on the ecosystems, and in particular on the forest. Here you see that there are a lot of interlinkage between the different drivers. One is the population, one is the economy, and even the technology efficiency. And as you can see, we have emission of different types of pollutants, and the effects are very huge on different ecosystems. And so it's very important to look at the different interlinkage between the different sectors. But if we talk about the forest ecosystem, this is not exactly true, because we know that environmental pollution was identified as one of the main drivers that is affecting the biodiversity loss, for example. And we even know that environmental pollution is one of the most relevant parts of the global change. But most of the researchers that are working on the biotic effects of climate change do not consider air pollution. On the other side, most of the studies on the distribution of pollutant and the biotic effect of pollutant neglect the effects of climate change, the issue of climate change. So it is important to conjugate these two very relevant topics. As the chairman said before, the forests are not only a carbon sink, but they have a lot of ecosystem service that provide a lot of ecosystem services. And this, as an example, I show some of them in the field of human health, medical provision, for example, and they are very important for food distribution, for food production as well. So a lot of ecosystem service are very important. So in this case, it's very important to protect forests. The UFRO is the organization where I belong, is an organization that is protecting, that is working on forests on 360 degrees. So it's a non-profit, non-governmental international network of forest scientists that are working on very different fields that are relevant for the forest protection. So we have something like 50,000 scientists, And this organization covers 125 countries. This is just to introduce my research group. My research group is called Air Pollution and Climate Change, and we have these different working parties. So we have competence on different topics that are affecting forest health, and including some very peculiar, such as radioactive contamination, and for example, yes, atmospheric deposition, ground ozone level, but even genetical processes in the forest. We have 33 officers. This is the percentage of women and men. And we are covering some of the countries, but not all, unfortunately. We have almost all people from Europe for the moment, but we are trying to increase the percentage from other countries. Recently, we revised all the drivers that are affecting forest health in this manuscript published on global change biology. And in this manuscript, we even define the strategic roadmap for the forest vulnerability under pollution and climate change. So we try to define what are the most important points we have to look at for the future. And this is a summary of what we found. First of all, I will show you later about the distribution of the monitoring sites that is not homogeneous over the globe. And yes, I will not talk about the satellite monitoring because it was already well explained. And even we found some information about what is needed, for example, for protection against nitrogen, sulfur, and phosphorus. Even some information about what is needed in terms of genetics. And then the last point is the application of the modeling, because at the end, all this data that we collect are needed to produce modeling, to validate the models, and to produce models, because at the end, we can monitor everywhere, we can monitor a lot of things, but at the end, to have a continuous layer of information, we need models. And the models should be good enough. Oh. It's not working anymore. Right? No. No. The pointer, no, non va avanti. It's not, oh, okay, now it's going. Okay, I will talk a little bit more in deep about the monitoring of the forest over the globe. And I will show you some of the most relevant networks that are present over the globe. First of all, the ILTER network. This is a network of networks. Indeed, there are 39 countries that have sites belonging to the ILTER. And we have even a network that belongs to the ILTER that is in Australia, the TERN network, where we have a lot of information about climate, but even about the ecosystem. For example, we have even some information in China, in Korea and Taiwan that belong to the ILTER network. So it's a very big network. Another network is FluxNet. This is divided into regional network. An example of this is the ICOS research infrastructure with more than 100 stations, including 32 forest stations. So not only forest, but forest is monitored as well. So this is another very important network. Another important network that is European is under the CLEARTAP, the Convention on Long-Range Transboundary Air Pollution, and this is including ICP forest, level 1 and level 2 sites, and even ICP vegetation, ICP modeling and mapping, and ICP integrated monitoring. This is another network that is more focused on forest, that is ForestGeo. It's a global network again, and I want to show you this map that is about the distribution of all these sites that I said before. And as you can see, we have another estimation, or not estimation, okay. We have a lot of sites in Europe, in the temperate zone, and the temperate forest, we know that is not the predominant type of forest, but we have a very big lack of data in some area of the forest. You see the distribution of the global forest is in green, and you see that the tropical area is underrepresented by monitoring site, and this is true even for the boreal forest. So we have a big problem in the southern hemisphere, in the monitoring distribution, and the same is in the boreal area. And this is a big problem that should be solved some way. How can we solve the problem? With the satellite information. Okay, I will skip this part because you said a lot about it. But another important source for information is the reanalysis of the data. For example, CAMS from the Copernicus system can provide a lot of information that you can use at the global level with a good resolution, even in space and in time. And as I said before, what is important is to derive models, because the models are very useful to obtain information over large domain. And what we can divide the models in three different types. First of all, we have to find an atmospheric modeling that is providing climate information, meteorological information, and air pollutant information. Then to find an ecological modeling that is able to predict the impacts of these drivers, meteorological and air pollution, on the ecosystems. And then the third point, the very important point, is to define the risk assessment. So what is the potential risk for the forest considering these conditions? So at the end, so the modeling and the measurements should interact in order to obtain a very robust model that can provide very good information on forest health. And with this, okay, I thank you for your attention.
I really want to thank all the panelists, except myself, for being so disciplined on timing. It is, more than it's a pleasure to introduce Lorenzo, an old-time friend. His title, what he does, is described in the program, but he is now the life and soul of Italian presence, in IPBES, which is the biodiversity equivalent of IPCC and a long-needed instrument.
Thank you, Gramenos, for introducing me. Actually, we are taking opportunity of your speech to synthesize our interventions, because you gave a very good picture, the context of what we are talking and discussing today. And I hope to be brief as my previous speakers. And well, I will try to present, before me, Alessandra mentioned the importance of treating interlinkages, nexuses between things. And this is the case about climate change and biodiversity loss, which are considered the major socio-ecological issues we have to face. And we, I will try to present in my speech also the opportunities that may come from looking at the interlinkages between climate change and biodiversity loss. Well, okay. Okay, so I would have imagined that Susanna would have presented this graph, but I need it really because it gives the idea of what's happening in the atmosphere about global warming. This has been deeply explained by Susanna, so I will go to the next one. On the left side, you have the evolution of the emissions of CO2 and other CO2 into the atmosphere due to the combustion of fossil fuels and cement production. And this is the major driver of greenhouse effects into the atmosphere. But on the right side, there is another important issue, which is the emissions due to land use change, mainly deforestation, and which accounts for about 14% on average in the period, in the previous decades, in terms of accumulation of greenhouse gases into the atmosphere. So it gives the first aspects of the complex interlinkages between climate change and biodiversity loss. So biodiversity loss, which is related to deforestation and land use change, contributes to climate change. On the other hand, you see here what figures have been provided by Anne before me. Just would like to mention the fact that about 80 million hectares of deforestation are represented by primary forests. Most of them are natural and so far undisturbed by man. So deforestation is a major driver of climate change, but also it's a major driver of biodiversity loss. And we have here some figures that maybe conflict with those presented by Anne before me, but well, it is just deforestation, gross deforestation loss. Okay, and there is another aspect about the interlinkages between climate change and biodiversity loss. 2021 was annus horribilis in terms of wildfires. About 150,000 hectares were crossed by wildfires, most of them on forests, and wildfires on forests produced about 4 million tons of CO2. It is not very much, it is about 1% of annual national greenhouse gases from Italy, but as Susanna said, every ton matters. So we need also to address forest fires as a mean to mitigate climate change and to reach Italian commitments in Europe and worldwide. So this is another aspect. Very few people are aware that bioenergy is still the major source of renewables in Italy. So this is a big problem. As you know, IPCC treats bioenergy as a renewable form of energy, CO2 neutral, even though we know that most or well, part of this energy is not sustainable. There's a big debate about this, but this is the reality, and we have to, to rely on bioenergy for energy supply in Italy. And this is still another aspect of the nexus between the two major socio-ecological problems, and we need a mitigation based on land to reach the targets in terms of halving the amounts of greenhouse gas production by 2030 and have net zero emissions by 2050 if we want to achieve the Paris Agreement target of 2 degrees. So this is part of my speech, And then we go to the question of biodiversity loss. In 2019 was released this well-known report from the IPBES. This report says many things, and inter alia the fact that about 1 million species are risk extinction, and these extinctions may be finalized in a few 2 or 3 decades. This is very, dramatic. This very well. I don't know what to say about this figure. You have to say to know that the number of species that have been inventoried are about 4 million. So 25% of species are under threat of extinctions. And this happens because of main causes, but it is important to remind that every taxonomic groups are interested by this rate of risk of extinction. And you see here, for example, it's not only a question of species, but you can see here about 70% of populations of the major vertebrate species are declining at an alarming rate. And the same for species habitat index, biodiversity intactness index, not important factors of biodiversity decline. And you have here the 5 major drivers, direct drivers of biodiversity loss. And well, of course, habitat loss, overexploitation of natural resources, pollution are well-known causes. And then we have 2 novelties in terms of biodiversity loss. One is invasive alien species, and the other one is climate change. So climate change is one of the main drivers of biodiversity loss. Scientists have confirmed that a couple of dozens of species have been extincted because of climate change, but climate change interacts with biodiversity in many ways, different ways. And then the year after the release of the IPBES report, the Global Biodiversity Outlook, which is based on data and information provided by member countries of the CBD, says that none of the 20 Aichi biodiversity targets were completely achieved. We went close to one of them, which is important, the percentage of protected areas worldwide, about 17% of terrestrial protected areas. And then the rest, well, we have to admit that was a failure. And the Global Biodiversity Outlook also provides options for recovering, to stop the decline of biodiversity loss by 2030 and reverse the trend by 2050 using 5 different options that have been incorporated in some way in the draft of the Global Biodiversity Framework, which is the agreement within the CBD process for the post-2020. I will be more detailed on this later on in the next slides. And of course, this 2 reports says that biodiversity is very important to contribute to mitigate climate change. Well, fortunately, something is changing in a positive way. You have here 2 paragraphs from the Glasgow Climate Pact. The first one recognized the interlinked global crisis of climate change and biodiversity loss. And paragraph 1 of the Glasgow Climate Pact again stresses the importance of protecting, conserving, and restoring nature and ecosystems, including forests and other terrestrial and marine ecosystems, to achieve the Climate Change Convention's long-term global goal. acting as sinks and reservoirs of greenhouse gases, but also, as Gramenos mentioned before, forest and natural bioma are not only carbon stock, carbon sinks, they act also for providing other benefits to people. And we know that these are important values for having nature and biodiversity. And just to mention the fact that during the G20 presidency of Italy in 2021, the communique mentioned the importance of nature-based solutions for achieving the dual objectives of climate change and biodiversity. And this is very important because the G20 countries, the most relevant economies in the world, have recognized the importance of using nature-based solutions or ecosystem-based approaches to address biodiversity loss together with other important environmental issues. Of course, also the draft of the Global Biodiversity Framework, the agreement for the post-2020 for biodiversity, includes, again, the importance of having nature-based solutions, and in particular, 2 of the 22 targets for the post-2020 Global Biodiversity Framework mention the importance of well-connected systems of protected areas and other effective area-based conservation measures. And also in Target 8, explicitly is mentioned the importance of using nature-based solutions for having at least 10 gigatons of CO2 equivalent per year to global mitigation efforts. Just on this target 3, I would like to mention, to underline this concept of other effective area-based conservation measures, because they are not conventional protected areas. They are measures that can be decided by countries, but the CBD has provided a guidance on how to identify and monitor other effective area-based conservation measures. Actually, with the Carabinieri Forestali, we have started also a discussion to use the so-called servitù militari. I don't know the English name for that, but I know that Canada, for example, has identified as other effective area-based conservation measures the servitù militari. So all servitù militari in Canada have become other effective area-based conservation measures, and they will be used for reaching these targets in 2030. So it is an important issue that needs cooperation between our government agencies and military corps. Okay, and then going ahead, also we have in place in Italy, in Europe, this important strategy bringing nature back into our lives, the biodiversity strategy for 2030. And again, we have 4 pillars. The first one is on protection, the second one on restoring. And again, on restoring, there is a special focus on nature-based solutions, which are explicitly mentioned. And in 2022, the UNEA 5 approved this definition of nature-based solutions. I will not go to read the text of this definition, but it is very important in terms of negotiations, but also for implementation of these measures. And we have here a graph taken from a paper by Griscom Italia in 2017. This paper says that it will be possible to reach 12 gigatons of CO2 mitigation potential using activities, plans, projects in forestry, agriculture, and management of wetlands and grasslands. And these measures may also offer multiple benefits in terms of biodiversity, of course, but also in terms of water and soil conservation. And just a few weeks ago, there is a refinement of this potential evaluation assessment, and basically they say that we still have a potential of 10 gigatons of CO2 per year by 2030, which is about, if I well remember, 1/3 of the efforts that the international community has to do to reach the Paris Agreement. And then, I'm sorry, this is in Italian, but just to mention the fact that for the first time, the IPBES, the IPCC, have produced a joint report looking at the linkages between climate change and biodiversity loss. And they have done in this report a chapter on nature-based solutions, and they have identified 4 categories of actions, interventions, for implementing nature-based solutions. And it's very interesting that the last one, the creation of nature-based solutions, which include, for example, the establishment, the setup of green areas in cities, around cities. And in this regard, I would like to mention an important initiative by the Italian government using the EU Next Generation Fund that aims at planting 6.56 million trees in cities and around cities, not only for things, but also for providing multiple benefits to citizens. I think this is one of the last one. Of course, we need money. This is a special report produced by the Nature Conservancy and another think tank, American think tank, saying that we need about $700 billion per year to restore, to protect nature. The introduction to this report has been written by our current Prime Minister, Mario Draghi, who says that we have to have nature as an ally, not to see nature as an obstacle or constraints to development. It's an important document that, of course, it is used as a reference for the definition of targets in terms of nature-based solutions. And well, the good news is that we know how to do this. We know how to do this. We have in the past many examples in Italy of restoration, new plantings, of course, for other objectives. But now we have the knowledge, we have the know-how on how to do nature-based solutions. And also in recent times, for example, in the restoration of Posidonia habitats, or restoration of sand dunes for reducing erosion on the right side, or protecting wetlands on the left side. So we have to start from these experiences, and we can reach this potential. And yeah, thank you so much.
Thank you so much, Lorenzo, also because we feel passion in your words, which is a shared passion. Give me 10 seconds to say that we are desperate about climate change, consider it as an inevitable doom, but only by doing what he said with forests, we solve 30% of the problem. By restoring degraded land, we solve 30% of the problem. There is another 30% that we can solve by eliminating food waste and organizing better food production and distribution. We're going towards doom just because we don't want to do things that are so obvious and could be, and there are all things that would improve the quality of our life. We have the last live intervention, and leaving for a conclusion the intervention from the United States. Yes, it is I give the floor to the representative of CUFA, Major Gianluca De Angelis.
Good morning to everyone. My name is De Angelis Gianluca, and it's a pleasure for me to be here to speak with you about these arguments. Possible to see? Okay, today I want to show you how our command used the new technology for the fight of the problem of the forest fire. And I want to show you two our activity. The first one is the website for the mapping forest burn, and the second is a practice case of how we have used the new technology to understand a particular type of mega fire in Italy, was born a few years ago. But before to go on, I want to show you who we are and what we do. The NIAB is a Nucleo Informativo Antincendio Boschivi, and is an idly specialist office inside the command forest, and he was established in 2000, and he specialized in activity of law enforcement. As you see, the NIAB is wherever in each part of the Italy, and cover all the Italian surface with different typology of command, repart, road group, station, and we cover all the Italy for our activities. But which are our activities? First of all, we carry out criminal analysis activity on the fire forest phenomenon. And to do that, we use, in special case, the new technology such as remote sensing data, GPS, different type GPS data. And we use software such as GIS, QGIS, and ArcInfo to merge all this data in the same data set. But for us, it's very important to have a network of the network of our Carabinieri of the NIAB reference directly over our territory, to apply this technology directly over the ground and over the area of interest. And our proposal is to carry out a specific training and education for the Carabinieri of Fire Forest Speciality regarding the activity of info investigation activity, and also to make a constantly upgrading of our staff of the military to apply what we want to explain to us. We use also we have more contact and collaboration with the Italian Institute of Carabinieri, such as Castel Volturno, for example, where we have one simulator to simulate the dynamic of the fire, but also the headquarters of forest in Sabaudia and in Città Ducale. In a special case, we have also more activity and collaboration with the university, because for us it's very important to have our support, special case, in particularly critical fire, forest fire. In fact, in this case, we use the algorithm development by the university to approach the study of this case of fire in different way. We use also a standard methodology as MEF or MEG to understand the dynamic of the fire over the ground, and we collaborate with the police activity regarding the observation, prevention, and repression of the fire in the wood area. You have just explained this, but I want to fix the point. The fire is obviously a main element of destruction of the forest and splashes, and it's very important to understand the dynamic of that, especially now regarding the global warming. Many investigations are done every year, and we have seen that 98% of the fire forests were caused by the hand of man, from the people, with or without intent, and only the 2% of the fire are natural or accidental. That value is important to have our activity to be specialized in this field of activity of prevention. For us, the investigation process for us is to understand, not only to understand the cause of the fire, not only to understand the physical process, but also to include any aspect of that phenomenon, such as the social, economical aspect. And we need to give the answers of some questions. For example, who committed the lead, where the event took place, what type, what tool are used for to start the file, and so on. As you see in this image, that are our process, the workflow to arrive at our goal. And for each step, we collected some data, for example, digital data typically, GPS type of fuel, slope, map, geographic information, and so on. And everything is included in a one digital file where we put inside our system to understand the dynamic of the fire. That is a typical situation. To understand the ignition point, we need to first define the fire perimeter with the GPS technology, for example. And the second step, the starting zone, to define the starting zone, the starting area, and at the end, looking for where it started the fire. So obviously the ignition point. That is a typical method to find evidence on the ground. In Italy, we have two important milestone. The 2000 and the 2021. In the 2000, we have the law 353. This law fixed the many particular points. The prohibition of to use the ground was crossed from the fire, to use it for 15 years with different type of use. So it's not possible, for example, to build a palace in one area where it's crossed by fire. Don't change the use of the ground. The second, in fact, you can see in these two charts, how the tender of the amount of the fire and extension burned wood area after this data was decreasing. Obviously, in the extension burned in the area, you see the peak, but that is, as I just told, the terrible year, the famous terrible year. Each year, 5 years, there is a strange situation. Another important law is the 155. The government asked to Carabinieri to make for each fire one survey to cover all the area and extract the perimeter for this area, and publish that in an institutional website. That is the origin of our forest fire geoportale. So we have made, and it's possible, it's free, it's possible to see directly in the web. We have made this geoportale where we put all our information regarding the fire forest, and it's split as region, province, and municipality. We can make a query to find what you want. In fact, for example, we are in Calabria. If you see in the circle, that number is the number of the fire in, for example, in that municipality. And if you go on in the button down, you see all the data, the information regarding national data, number in fire, regional data, and so on. If you go on, you click and you see all the information. Obviously, this geoportale is regarding the fire of 2021 because it's the time of the start of the law. I spoke about two laws, 353 and 155. So for us, it's very important to be sure of what we put inside this geoportale, because if you wrong the area, in that area is not possible to build nothing for 15 years. So to do that, we need to be, for example, the information we can extract. To do that, we need to make one redundant system to have the same value in different way, and to make a comparison of the data. And for that, we use the CISIFA, EFIS, and system SIA. Allora, CISIFA is one system, one report inside the Carabinieri forest, and is where we we put every information. The second element is the Copernicus data, that is open data. They send us the warning where should be one one fire, but it's not, I don't know if it's correct or what we, in effect, the one is for the field of agricultural or wood area. The second step, we use one algorithm of the university. In fact, as you can see, the university make another apply one algorithm for extract one different information respect the FIS and give us the accuracy for each pixel that is block for to know if in effect vegetation or not. And at the end we put all together for to see if it correct, the value is correct. Okay. Now we have more type of information. More, someone is free, someone is not free, but it's possible to use it. And we understand it's possible to integrate all this data in the software as GIS, but also together to access new information. And for example, we have understand how the wind in our activity is the real engine of the fire. Because if you study the wind, we can understand the dynamic of the movement of the fire. So we need to understand, we need to study the weather condition of the area, the pressure, the humidity, the temperature, the wind, and special case the surface. Because if you change, depending on the surface, obviously the movement of fire will be different. Mi può mandare il video? No? No, è dentro. Sì, sta dentro. La slide successiva. The next slide you should have the video. It's black. Okay. That is a particular case, a real situation. We are in the Sardinia. If you know, in the 2021, there was a mega fire, the bigger fire in Italy of the last 10, 20 years. In that situation, we are in the 2021, the day was the 23, 27 of July. We used a Pangea in a platform cloud, who we have used it to import inside every type of data, to merge it everything and to have made one modeling of the surface. We have put inside this type of platform every type of information from different sources. In special case, we have used the information from public station, for example, ARPA or other information, to merge the information from temperature, pressure, and wind direction. Because this fire was very, very strange fire. The fire started from one point in the 23 of July, and in the first step was extinguished. But in the day after, the fire was wherever in the north of the Sardinia. In the first moment, we supposed there was a problem of some attack of different people together, because it was possible to have the fire in all different parts of Sardinia contemporarily. But we have made another approach of this activity, this fire, mega fire. We have started to study the contour condition. First of all, we have, as you see, that is in this is an image of Sentinel-2 of 25. The first thing was we have studied the condition. In that time, there was two big mass of air, one high pressure in the middle of Mediterranean and a low pressure in the middle of near Spain to France. The low pressure was moving, and that when the low pressure was moved, called back the high pressure called back hot air from the north of Africa. The first consequence of that was one increase of temperature of 5-6 degrees in one day. See, the speed of the wind was changed completely, and the power of the wind was changed. The wind in this day was 25-30 30 meters per second, about 1,000, 1,010 kilometers per hour. And the wind continually turned in all directions. That condition have made the strange situation who the air was moving up and carry up also elements of the ground such as ash or element not completely burned and falling down in another part much far away respect to the starting point. In this element you see how the temperature was changing and in different day the temperature was just in 40 degrees in this part of element. The humidity was changed, was degree the humidity factor, and we see also the direction of the wind. We have made one model of all our data. We have made one grid, 1 kilometer for 1 kilometer to make our modeling of the temperature, wind, and pressure. We have made a modeling for the pressure from 10 meters to 2,000 meters. The same for the wind direction. As you see, you can see the model for the surface direction of the wind. And in the image, in the moving, you see how the velocity of the speed of the wind was continually changing, and as a power and as a direction. That all this is only to explain how it's possible to use other information to extract and arrive a new typology and new methodology of the investigation for a particular case such as that. For me, it's finished. The present. Ecco, questa è una cosa importante. Look at the direction of the wind.
Okay.
Thank you very much. I was impressed by the quality of the model and the integration of information. Now, in some cases we say, may God assist us. In this case, we say, may technology assist us. We have an important intervention by Professor Mozart, which was recorded, and it normally played well on a normal PC. There are some doubts about its functionality on this projection system. We will try to.
Thank you for inviting me to present at this important conference.
It works. It seems it works because we hear the audio. Please, if you can launch.
Thank you for inviting me to present at this important conference. I am Keith Mosier with the USDA Forest Service Rocky Mountain Research Station in Flagstaff, Arizona. I wish to acknowledge my co-author, Dr. John Shaw, also with the Rocky Mountain Research Station in Ogden, Utah. I further wish to acknowledge the support I received during my time as an Embassy Science Fellow at the U.S. Embassy to Italy in Rome, and support by the Arma dei Carabinieri during my time there. In business, a good inventory is essential. It is necessary to understand and manage forests too. Concern over the timber supply in the 1920s led to the development of the American National Forest Inventory. American forests were harvested from east to west as the country developed in the 1800s, and there was a poor understanding of what remained. The law that started FIA, which was originally called Forest Survey, also established Forest Service research. The early focus was on the major timber-producing regions, in keeping with the language of the law. This map illustrated the emphasis on the prime timberlands of the Pacific Northwest and Southeast, which are primarily sources of softwoods, and the upper Midwest, which is a hardwood source and an area of important industries. The last 3 states in the continental U.S. were completed in 1962, so the first full cycle of inventory in the coterminous 48 states took about 30 years to complete. After that, the inventory continued on a state-by-state basis, with periodic inventories occurring on a targeted but rarely achieved 10-year cycle. There were several independent Forest Survey units during this period. However, users were beginning to rely on the data, and in response, they demanded more detailed data provided at a higher frequency. Congress responded to these demands with the 1998 Farm Bill, which contained a provision that mandated annualized inventory on a 5-year repeat and reporting cycle. However, funding has never been adequate to achieve a 5-year cycle in all states, so a compromise of 10 years in the West and 5 to 7 years in the East has been used. The 5-year plan for all states does occasionally return to the table for discussion. This kickoff article by the National Director described many goals of the program that were, in addition to the design change, including timely delivery of new data to the user community. The past 20 years have been the most stable period in FIA history, although it took a decade for annualized inventory to be implemented in all states. Recent changes tend to be related to changing technology and the ever-increasing demand for data. This graph is from a publication by our colleague, Dr. Wade Tinkham, and his co-authors, showing the progression of the forest inventory from the 19th century to today. In red, we see the various laws that defined our agency, influenced its management, and affected how we conduct inventory. In blue, we see our internal agency actions that implemented the differing inventory practices over the years. And in green, we see how improvements in technology aided the inventory efforts. Today, there is a spatially unbiased continuous inventory across all CONUS and Alaska, with inventory of the islands being periodic due to their small size. On the ground, the inventory looks like this, with phase 2 being our production inventory. Spatial intensity is 1 plot per 2,400 hectares over the course of a full cycle. The phase 3 protocols that were implemented at the same time as annualization, but at a much lower spatial intensity, have been modified over time, with some expanded to the P2 plot set. This slide illustrates the patterns of plot locations for 3 panels or years of a 10-panel cycle in the state of Colorado. Every year's sample is spatially unbiased. But we collect enough information at every plot location to be able to populate this matrix and measure trends in land use and land cover change. This feature was not implemented until the 2nd decade of annual inventory, but we are in the process of backfilling the non-forest data using information that was used to make the forest non-forest call during the 1st decade. Forest land is still our primary focus, although all lands inventory occasionally comes up for discussion. This map shows the forested plots in FIA. The FIA database currently consists of 105 tables, the core of which are shown here. Related groups of tables are coded by color. The program goal is to update each state's database within 6 months of the closeout of the previous year's inventory and publish it to the FIA Data Mart. Our mandate under the Farm Bill is to produce state-level reports every 5 years for every state, but FIA does reports. In general, the source data used for these reports are the same data as are published to the Data Mart, so the general public gets access to the data at about the same time as FIA analysts start writing their reports. In addition to the complete set of data, which is referred to as FIA-DB, FIA program provides many public-facing tools that can be used to generate summary tables. This accommodates a wide range of user skills. We will now demonstrate the power of annual FI data to examine trends. For the purpose of illustration, we have worked up a short example that highlights the value of annualized inventory. Although different in total area, the state of Alabama and Italy have similar forest area, so an annualized Italian inventory that is implemented similarly to FIA would be capable of the same level of data resolution. This is an outline of Italy superimposed over the southern United States. Alabama is in the center of the picture. These are selected major species in Alabama, showing the total volume trends over all inventories available, 3 periodic inventories, and an annual since 2001. Each dot represents an inventory year. Note the greater responsiveness of the inventory estimates once the annual inventory started. There are several potential explanations for these observed trends, but we will not explore these here. However, Alabama is a major wood-producing state, and loblolly pine, or Pinus taeta, is its most important species. At the same scale, the trends for species ranked 2 through 8 in total volume, the remaining 3 conifers and 4 broadleaves look modest in comparison. Combining the groups, somewhat different patterns emerge. Note the dramatic increase in volume of the top 4 conifer species. The periodic and early annual inventories show similar trends, but there appears to be an inflection point around 2010. There could be several explanations of why this has happened. Fitting lines to different segments of annual data confirm inflection points, at which the annual increase in live volume in the current decade is nearly 3 times that of the previous decade. The timing suggests a connection to the Great Recession, which is closely related to the changes in housing markets. Harvest reductions would logically result in the greater live volume found in subsequent inventory years. Emergence from the recession did not result in full resumption of harvest rates, and the combination of high lumber prices and COVID-related activities seem to have extended the trend. Although we show this for illustration here, economic factors are explored more thoroughly through the timber products output component of FIA. One important thing to note about this trend is that interpretation would be limited if Alabama was still under periodic inventory. For example, periodic to periodic comparison would miss the inflection point and underestimate the current rate of volume accumulation, possibly by 70 million cubic meters by 2025. A corroborating source of data can be imagery-based products. The Landscape Change Monitoring System, which uses FI as image training data, captures forest cover change on an annual basis. In these images, the varying shades of yellow-orange represent different years within the observation period. The pre-recession pattern for central Alabama looks like this, showing a very active industrial forest landscape. In the following decade, the amount of disturbance from harvest is noticeably lower. Zooming to a smaller area, we will be able to see more detail. Here is that smaller area before recession. Note the larger amount of activity, and after recession. In the previous sequence, remote sensing and plot data were effectively independent, but the remote sensing data verified and mapped the plot-based results spatially. The next example will fully integrate plot data, maps, and forest projection capabilities. TreeMap is a product of the U.S. Forest Service Fire Lab. It is closely tied to FI plot data, which makes it particularly useful. FI samples forest on a sparse grid. The non-sampled area can have much higher variation than that represented by the plots in the area. TreeMap uses FI plots from a much greater area and imputes FI plot control numbers to all forest areas. For example, the magenta pixels are assigned a plot number from elsewhere, as are some of the other colors besides the light and dark blue. These control numbers provide a direct linkage from pixels to tables and data in the FI database. For example, if mapping forest type, the landscape is relatively homogeneous, mostly ponderosa pine with some aspen and juniper present. However, if mapping attributes such as volume or biomass, landscape heterogeneity is evident. In the next series of slides, we will present some what-if scenarios from northern New Mexico. We will use FI data, the Forest Vegetation Simulator, and Tree Map. There is not enough time to discuss the Forest Vegetation Simulator here, but it is an individual tree, distance-independent growth model that can be used to model a wide range of management actions. Using the fire and fuels model, fire simulations are sensitive to fire weather, stand density, composition, etc. For example, these two stands have differing density and composition, but are subjected to the same fire weather and have much different outcomes. For the next illustration, we use the landscape of northern New Mexico, which is a naturally fire-prone landscape. This image is from the tree map data showing the FI forest type distribution. Since we have the area of interest established, the plots represented by map pixels can be extracted for simulation. All 1.7 million plot visits in FIDB are available in the format used by FVS without any need for user modification. FVS simulations results are stored in an SQLite database, which can then be attached to Tree Map to illustrate the fate of each pixel for any future scenario. Many fire and management scenarios are possible, but in this case, we will show a 100-year simulation with dry conditions and fire affecting a large number of stands in 2060. Cooler colors are higher density and warmer colors are lower density, so we expect higher density stands to be affected more severely. In addition, this simulation is primarily confined to stands with ponderosa pine component. In the following sequence, watch the changes in the blue-green areas at the center of the image. FVS not only shows the impacts of fire, but also some recovery as trees grow post-fire. In the summary, we introduced the U.S. Forest Service FI program with a brief overview of the program's history. We then touched briefly on production, including data collection, summaries, and dissemination to users. We presented an example of the analysis opportunities using annualized data from the state of Alabama. And finally, we presented the new analysis ecosystem where FI data, Tree Map, and the Forest Vegetation Simulator are combined to create unique information products. Thank you very much.
Okay, fantastic. Although he's not present here to listen to our thanks for this interesting presentation, still thank you, Professor. You to tell me if this is what you want me to say at the plenary. Or we can have a short discussion, because besides, everybody putting forward some points of view, some knowledge to be shared among us, we are professionals and things like that, we will have to convey a message to the plenary, which is functional to the role of armed forces. Do we want to have a 10 minutes debate, maybe everyone underlining the message that you want me to convey, or shall we stop here and you trust me to try and synthesize? I know that stealing lunch break time is almost a crime against fundamental rights, so I leave it to you. Okay. I see a certain shyness that probably means I don't want to be the first to say that I'm hungry.
Maybe I can say something. Maybe I can propose a third road to go on. If you can summarize to us what you have in mind,
okay.
Just and then we can eventually say if we want to add something else.
Okay. So what I thought I could say is that we recognized one basic truth. That is that when the environment collapses, it is not only a problem of the environment. And this is serious because until not so long ago, this was our idea. The environment is a problem of the environment. We understood that the collapse of environment is actually a problem for mankind. It brings over destabilization and conflict, economic problems. And this has an implication. If armed forces were born to protect people, now that we understand that environmental decay affects people, it is naturally a mandate of armed forces to protect the environment. Based on this, we explored some approaches, and we also explored the state of the art. Through an illustration of current situation and scenarios of climate change based on the IPCC latest report, through exploring the interactions of this dimension with biodiversity and other components like pollution. And then some practices were illustrated, which are, for the moment, in the level of monitoring, which is absolutely essential because we all understood that without a serious monitoring, we cannot use sound basis of decision for action. And then I would give a hint of the various approaches that were presented. Of course, I would also refer to the national appreciation of the forest dimension, but also to the international FAO driven survey. Then mention the engagement in developing a new methodology that is useful for Italy, but could also be exported, looking at the adoption of the new satellite constellation. And I would mention what the advanced technology that has been achieved in the control and monitoring of forest fires and all the things that have. This basically would be what I would like to tell if it was me. But I don't know if you agree with this.
A short comment, the next generation is coming quite fast because of course these takes long time. In the meantime, we can exploit as much as possible the current one with the activity made by Colonnello Papito using automatic approach for analysis investigation to provide quantitative information. That is the main point in order to have the possibility to plan and put in action some suitable approach. Something like this.
Yes, this was included because now I made the summary of the summary, not to repeat to you all that you've, but it's written down, and this is what I would convey, but besides, quoting some aspects of other aspects of your presentations, the I think the important thing is, do you agree with this message? I mean, protecting environment is naturally part of the mandate of armed forces and security forces because they were born to protect people. And now we have understood that if you do not protect the environment, you do not protect people. Do you think this is agreeable as a message to the, besides trying to summarize?
Yes, this is the right way. Yes, this is the right message that we have to give to in the plenary session. And this is also the message that I would like to share with all people that are connected with us in this day, because this is the real role of the law enforcement like Arma dei Carabinieri, to stay with the people, to solve the problem of the people. One problem is the environmental and the global change. And so I think that your conclusion is perfect for this session. Thank you very much, Chair. Thank you very much, all people that participate. And I think that we can go to eat something and wait for the plenary section. Thank you very much.
Thank you so much.